This is going to be a quick demonstration of how the model built in ArcGIS Pro works. So first, you can start off with USGS and GLOVIS, which is the United States Geological Survey Global Visualization Viewer. If you were to launch the application, it would look like this. And it'll just take you to a map. Now you do need an account, which is free to set up in order to download the data sets. And we will be looking at Kamloops today. And then, so for selected data sets, you want to go to Add, and we'll be using Landsat 8.9. So you just click that, Add Selected Data Sets, and then it'll start popping up with ones. And then you can add metadata filters, which we don't need to be doing today, but those are the options. But we will do a common metadata filter. So we will do acquisition date, and we can do cloud cover, seasonal. But at the moment, we're just focused on the acquisition date, and we will be looking in August. Now, Landsat 8 covers the Earth every 16 days, but we will be focusing on August, and I know the date is going to be the 19th, but we'll just look for there, and then we don't need that. So here's the naming convention, so that's 0824. But we want this date. So then you would hit download, and the options would come up, and the one that you want is this one. And we'll just minus that window into ArcGIS Pro. We already have that data downloaded, and it's in this folder. And we keep the naming convention from USGS. This is the model, the raster calculator. So this is for creating a normalized difference vegetation index. We'll just open it up, and then this is the ArcGIS Arcade equation. And to create an NDVI, it is band 5 minus band 4 divided by band 5 plus band 4. And you just need to use float to create, to keep it as a positive, negative integer value with decimals. Okay, so they just added there. And then if you were to run it, creates the raster, and then this is used to create a polygon of the raster. So it creates a domain, a line, and then a polygon of it, and that is used to clip the features from the active fires within that area. And then here you extract the values developed from the NDVI onto the points, and that'll be added to the attribute table. And then here, so this is a true color composite of the scene that we just downloaded. Here you can see the smoke from the fires. This is just used as a reference point. We don't have anything automated to create these, but that could be something that could be done. And then the normalized burn ratio is here, and the lower values signify, or the negative values signify the burned area, or the higher burn severity. And then this is the NDVI, and the higher, the green areas would be healthier vegetation. The really dark orange, red, is water. And then that orange would be smoke, which we kind of remember from the true color composite. But then along here, kind of all down in these valleys, you can kind of tell that it's a bit of a weaker vegetation, more likely to be burned, or has already been burned, similar to showcasing the values here. And then if we were to open up the attribute table here and scroll over, this is the added field just called raster value, and it is for each of these points, which are the active fires. And then just to make the naming better, we add that and then calculate it just to equal the same. And then this is the other model, very similar to the NDVI, but it's just another one set up to create a NVR. The one thing to remember is just to make sure that the naming stays